At 10:00 hours local time, the U.S. Navy destroyer USS Chung-hoon entered the Taiwan Strait alongside the Canadian frigate HMCS Montreal. It was a routine freedom of navigation transit through international waters, the kind U.S. warships have conducted for decades without requesting Beijing's approval. 30 nautical miles to the west, a Chinese PLA Navy destroyer decided to contest it. At 10:07, Chung-hoon's radar operators watched the contact accelerate from 15 knots to 28. Course change, intercept geometry. This was no longer shadowing. The Chinese ship was closing with intent. Updated calculations placed closest point of approach inside 2,000 yards. Across the ship, sailors moved to stations they had drilled 1,000 times. This time, it was not an exercise. By 10:12, the Chinese destroyer had closed to 22 nautical miles, roughly 55 kilometers. At that speed, it would reach weapons employment range in under 17 minutes. The tactical action officer pulled up the threat library and reviewed what Beijing had brought to the encounter. Inside the approaching destroyer's vertical launch cells sat what Chinese state media calls the carrier annihilator, the YJ-18 anti-ship cruise missile. Western analysts consider it the most dangerous naval missile currently deployed by the PLAN. On paper, the reputation is earned. The YJ-18 is 8.22 meters long and weighs approximately 1,580 kilograms. It attacks in 3 distinct phases. A solid fuel booster ejects the missile from the launch cell and accelerates it to cruise speed. A turbojet sustainer then takes over, pushing the missile at Mach 0.8 while it skims just 5 to 7 meters above the sea surface, low enough to blend into radar sea clutter. For roughly 180 kilometers, the missile flies this profile quietly, guided by inertial navigation corrected by Beidou satellite updates toward the target's predicted position. Then comes the terminal phase. The cruise stage separates and a second solid rocket motor ignites. In 4 seconds, the missile accelerates from Mach 0.8 to Mach 3. Terminal altitude drops to just 3 meters above the waves. The supersonic warhead covers the final distance in under 50 seconds. At impact speed, the 300-kilogram warhead delivers approximately 150 megajoules of kinetic energy, comparable to a car striking a wall at 600 miles per hour, followed immediately by detonation. The Chinese destroyer carried 64 vertical launch cells. Standard loadouts include between 8 and 16 YJ-18 missiles. At current range, every one of them could reach Chung-hoon in under a minute from launch command to impact. Chinese naval doctrine calls this a saturation attack. Fire enough missiles simultaneously, and some will inevitably overwhelm defensive systems. If defenders can engage 4 targets and attackers fire 8, 4 get through. Simple math. At 10:15, as the Chinese ship continued to close, Chung-hoon's combat systems operators were not concerned. They were calm, because that math has several fatal flaws, and every one of them was about to become Beijing's problem. At 10:18, Chung-hoon's electronic warfare team pulled up the YJ-18 seeker profile and began preparing the counter solution. What the team uncovered made it obvious why no one aboard the American destroyer felt any pressure. The YJ-18's active radar seeker operates in the X-band, between 8 and 12 gigahertz. That is not secret data. It is basic physics. And physics hard-codes weaknesses that no patch or software upgrade can erase. X-band gives excellent resolution in the final phase of flight. Short wavelengths cut cleanly through sea clutter and outline ship structures with precision. But that same frequency choice forces the seeker to emit constantly. Every pulse advertises the missile's location. Every reflected return exposes its bearing and angle of approach. From Chung-hoon's combat system, a YJ-18 in terminal flight might as well be broadcasting a bright sign that says, "Engage now." That vulnerability gets worse when paired with the SLQ-32 electronic warfare suite mounted on the destroyer's superstructure. That system has been countering X-band seekers since the late 1970s. Its coverage spans roughly 5 to 20 gigahertz, placing the YJ-18 seeker squarely in the center of its kill zone. Modern variants do not just listen. They deceive, overwhelm, and fabricate false targets that drag incoming missiles away from the ship entirely. If the attacker attempts to overpower the jamming by increasing seeker output, the missile creates an even larger problem for itself. The stronger emission becomes a beacon. Instead of finding the ship, the missile provides a clean targeting solution for American interceptors guiding themselves straight to it. The terminal sprint introduces another issue Chinese engineers cannot engineer away. Accelerating from Mach 0.8 to Mach 3 requires burning roughly 200 kilograms of solid rocket fuel in about 4 seconds. That process is anything but subtle. The infrared plume is detectable from tens of kilometers away. The instant the second stage ignites, every IR sensor on the defending ship knows exactly where to focus. The missile effectively lights a flare across the horizon, announcing its own attack run. Stage separation only sharpens the picture. When the subsonic cruise body detaches and the supersonic warhead takes over, sensors register abrupt changes in radar cross-section, velocity, and altitude. For roughly a second and a half, the weapon transitions between flight regimes, creating a brief period of aerodynamic instability. That moment simplifies tracking calculations instead of complicating them. Then there is the maneuvering myth. Chinese sources advertise 10G terminal evasive moves, but those maneuvers are pre-programmed. The missile flies a scripted weave written into its guidance software before launch. It does not adapt. It does not react to interceptor launches or defensive fire. It executes a routine authored by engineers working from simulations, not combat telemetry. The YJ-18 was optimized to strike ships that do not fight back. Chinese test events use cooperative targets, radar reflectors mounted on barges, or decommissioned hulls sitting still, with no electronic warfare active and no layered defenses online. Under those conditions, performance looks impressive. The underlying design traces back to the Russian Club missile family, which Beijing reverse-engineered to create the YJ-18. In more than 3 decades of service across multiple navies, that missile lineage has never scored a successful hit against an Aegis-defended warship. Not once. In just 14 minutes, this encounter showed why American destroyers still dominate the world's oceans. As USS Chung Hoon calmly tracked a Chinese warship closing inside 18 nautical miles with no urgency and no doubt about the outcome. Powered by the SPY phased array radar, a cornerstone of U.S. naval superiority, the ship maintained constant 360-degree awareness, electronically steering its radar beams in microseconds while monitoring warships, aircraft, and commercial traffic across hundreds of miles. Linked into America's cooperative engagement capability, Chung Hoon did not stand alone, drawing targeting data from airborne early warning aircraft and other U.S. assets to see missile threats long before they could threaten the ship. Inside her Aegis combat system, high-speed processors continuously calculated every possible hostile move and every American response, backed by a vertical launch system loaded with proven standard missiles and advanced SM-6 interceptors. By the time the Chinese destroyer reached 14 nautical miles, it was already deep inside an American engagement envelope where any hostile action would be detected, classified, and countered in seconds. A quiet reminder to older generations of Americans that decades of investment, discipline, and technology still keep the U.S. Navy firmly in control at sea. The Chinese captain was betting everything on one belief: that the United States would not fire first. And while that assumption held, nearly everything else he trusted did not. The calm aboard USS Chung Hoon was not posturing, but confidence earned through combat, built on more than a year of real-world missile defense in the Red Sea, where identical American destroyers defeated hundreds of cruise missiles, ballistic missiles, and drone attacks using the same Aegis system the same radar, and the same weapons now tracking his ship. Each engagement sharpened U.S. Navy performance, with combat data analyzed, software updated, and lessons pushed fleet-wide in weeks, creating a living system that improves after every fight. China, by contrast, brought test-range assumptions into an environment shaped by electronic warfare, jamming, maneuvering targets, and return fire, conditions its weapons had never truly faced. As the distance closed to 10 nautical miles, missile math collapsed into seconds, and the balance shifted entirely to the side already locked on, already calculating, already proven, backed by decades of American naval experience, disciplined crews, and systems that do not rely on theory but on results. Chinese military forums like to line up specifications and declare victory on paper. But this encounter showed why Americans who have watched decades of naval combat know better. Because wars are not won by raw numbers, but by systems that can think, learn, and adapt in real time. While China's guns and close-in weapons look impressive in charts and brochures, they rely on old gunnery logic that fires, observes, and hopes, whereas the U.S. Navy's Mark 45 gun and phalanx defenses continuously measure every shot, correct instantly, and tighten accuracy with each round. As the Chinese destroyer pressed inside 8, then 5 nautical miles, its missiles were already neutralized by electronic warfare, its radars were blinded, and its gunnery advantage dissolved under American fire control that knew exactly where its rounds were going and adjusted faster than any human crew ever could. What remained was a stark lesson familiar to older Americans who lived through the Cold War. Technology alone does not decide fights, experience does. And in that moment, the United States Navy was not guessing, it was calculating. By the time the Chinese destroyer closed to just 150 yards off USS Chung Hoon's bow, the rules of naval combat had completely shifted. At long range, American systems, Aegis radar, SM-2 and SM-6 missiles, the Mark 45 gun, and phalanx CIW dominated, tracking missiles and correcting fire in milliseconds. At point blank, none of that mattered. The physics of two 8,000-ton ships moving at 22 knots replaced technology with steel, angles, and collision energy, potentially catastrophic for both sides. The Chinese captain's aggressive maneuvering was the only tactic left to offset overwhelming U.S. combat advantages, exploiting China's larger fleet numbers. Chung Hoon's captain calmly reduced speed, cutting collision energy while maintaining course through the Taiwan Strait, holding discipline under 6 tense minutes of extreme proximity. At 11:38, the Chinese ship finally pulled back, completing a high-risk demonstration of Beijing's close-quarters tactic, while U.S. and Canadian crews documented every second, creating footage that would circulate worldwide as a stark lesson. American naval systems dominate at range, but close-in maneuvers remain a dangerous lever in modern naval strategy.